This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. SignalWire real-time video technology allows you to create interactive video experiences that were previously impossible. SignalWire gives developers access to broadcast-quality, ultra-low latency video for everything from video collaboration tools for film and TV studios and Fortune 500 enterprises to engaging virtual events. They can even assist with one-of-a-kind, fully interactive virtual concerts. See why the future of video communication is being built on SignalWire. Their easy-to-deploy APIs and SDKs are available in most popular programming languages. SignalWire is a complete unified platform for integrating video as well as voice and messaging capabilities into any application. Try it today at signalwire.com and use code SERadio for $25 in developer credit. Go to signalwire.com, that's signalwire.com, and use code SERadio to receive $25 in developer credit today.
For Software Engineering Radio, this is Robert Blumen. I have with me today Leonid Shevtsov. Leonid, or as he goes by Leo, is a software architect at Railsware, a company that offers email testing products. He has over 13 years of experience building software for the web. For the past year and a half, he has been developing a mail transfer agent. We will be talking about email, generally transactional email and bulk email. Leo, welcome to Software Engineering Radio.
Hey, Robert. It's nice to be here.
Would you like to add anything to your background that I didn't cover?
That MTA has been in 2 years in development now. It's taken a while. SMTP is a fascinating technology. I'm excited to talk about it.
We started out thinking about transactional and bulk email as a topic. I wanted to spend some time talking about email generally because we all use it, but it's probably not as widely understood as some newer technologies like HTTP. So let's start out talking about email, and then we'll talk about some more modern applications. Are you familiar with the history of email?
Not really. I'm not much of a historian, but I can tell you that SMTP is pretty much as old or older than the web. And it's pretty amazing that it survived this far. It's a very open, I would say it's the most open messaging format on the internet. And in these days when we take much care into decentralization and moving away from just allowing people to participate in a platform, SMTP has allowed individual people even to participate without any center from the beginning. It originated in universities, so every university had a server with the people on it, and sometimes they exchanged mail on the server, and that was relatively easy to do. But then what if you want to send mail to someone outside of your own university or domain, as we now call such things? So that's when SMTP was born, and it is basically a protocol to send mail from one domain to another. That's what it is.
SMTP being an acronym, what does that stand for?
Oh, it's just a simple mail transfer protocol or simple message transfer protocol. Doesn't say much. So SMTP, as I said, is extremely decentralized, and all you need to send mail is a domain name. Or perhaps you can even get away with an IP address, but you really want a domain name. And once you have that, you can send mail. You can do that from your own machine. You can do that from your application server. Or maybe you should not do that because of reasons that we'll talk later. It's fascinating that while SMTP was designed as a protocol for humans, now it's the vast majority of emails is sent from automated systems. It's bulk mail, and the worst of bulk mail is, of course, spam messaging, and protecting people from unwanted mail is a huge, and it's the most important thing going on in email for years and years, and there's no end in sight in that matter.
I want to situate SMTP. Let's go one level higher from where we are. What is the overall structure of email delivery?
So SMTP is a text protocol, just like HTTP. And to deliver mail, you just connect to a port. So that would be a port. For clients, it's usually 587, and for servers, it's 25. And then you have a text dialogue with the server. So compose and send a mail from your machine. Your mail app will communicate with a mail transfer agent, which is a server that runs SMTP protocol, and it will queue your message for delivery. And in the next possible moment, which hopefully is like within a second, it will determine through the DNS system what is the recipient's mail transfer agent, connect to it and deliver the mail. And the recipient transfer agent will put the mail in some form of a mailbox, and usually let the recipient know that there's a new message. And then the recipient can go and use one of the standard mailbox protocols, of which there are two, POP3 and IMAP, and read the message.
Does the mail go directly from the sending SMTP server to the recipient, or can it transit over intermediaries or proxies?
Yeah, that's an interesting question. So the way the protocol is structured, it seems like there's multiple servers in the chain, and you would think that there's, like, to deliver mail, it has to go through hops, like you would see in an IP packet communicating. Actually, there's usually just two servers, the sender server and the recipient server. And what might happen is that either of those have several servers in their internal chain. For example, there's such a service on the web as a pre-filter that will reject spam messages. So you can that is another kind of SMTP server, SMTP relay, that you use in place of your own SMTP, and that it will filter the messages and it will forward the legit messages to your MTA. So then you would have two servers on the receiver end of the SMTP message flow. And on the sender end, for example, maybe you have some intranet server for your enterprise company or university, which will then go through a relay before leaving the intranet to go to someone else's MTA.
Let's start out with an email address. What are the components of the email address?
Yeah, so as I said, all mail is attached to a domain. So the domain is what you see before the @ in an email address, and it defines where does your mailbox live. So it defines where to send mail so it gets to you. And the part to the left of the @ is it's not your username. It's actually not well defined, because the behavior of that part depends on the specific mail server that you're running. Well, it's usually the name of a mailbox on the server, but it doesn't have to be. It's just some identifier.
Looking more in depth at the domain name, the sending side will use DNS to locate the recipient. What kind of DNS query does it make? What does it get back?
Yeah, so there's a standard DNS record, which is the MX record, which points to the mail server for a specific domain, so a mail domain. That record specifies where is the mail server for your domain and where would an MTA connect to send mail so it is received by your domain. Because in many, many cases, the domain that is, for example, serving the website is not the same domain which would receive mail. That would be inconvenient. So you can define a separate domain name for the mail server, or multiple.
I want to clarify, do you mean I might have a domain, or you might have a domain, say it's mail.mailtrap.com, and we're going to send mail there, or you might use mailtrap.com, but the MX record would have a different IP address than the website?
The difference is in the domain name, and the IP addresses, they don't matter as much. Let's have a more familiar example. So if you're using Google Apps for your domain, so you have softwareengineering.com but you're actually using Google Apps. So you don't host your own mail server. It's served by Google. So the MX record for the domain would then be something like aspmx.something.google.com. And when I want to send mail to softwareengineering.com and I compose a message, then my MTA will look up the MX record and will see that it has to send the mail to Google, which is another fascinating thing about SMTP and mail, that while it is designed and imagined as a decentralized protocol, it's the vast majority of mail is hosted on the same big corporate servers like Google.
Is there an authentication component for the user to send an email?
Yes, of course. As any other service, you have to authenticate. So the authentication happens on the first leg of the flow when your user application connects to the first submission agent, the first MTA in the chain. It will authenticate, and it usually requires a username and password. And then the rest of the way, the mail is actually not authenticated in that way. So the rest of the communication is literally open for anyone else. That is a big challenge in delivering mail.
What are some of the problems caused by that?
In 2 words, that means that anyone can deliver a mail that looks like you sent it. There's no mechanism stopping that. There are mechanisms that would allow the receiver to verify that the message is sent from you, but anyone can try to just connect to recipient's MTA and deliver a message from anyone in the world.
In practice, is that something that happens a lot?
It does happen a lot with spam mail. There are pretty good mechanisms to detect the mail before it gets to a user, because people are easy to confuse and computers are sometimes less so. However, the idea of spam is that if you send a billion messages, then maybe 1,000 comes through and you have some result. So they just find strength in numbers and abuse the mail system with much more mail than normal.
If I understand, then any computer anywhere with an SMTP server could look up another SMTP server and send a mail and say, this mail is from Robert Blumen at sc-radio.net. There isn't anything in the protocol inherently that would verify or reject that as being not true.
That is correct, that anyone can connect and send such an email.
So what are some of the mechanisms that have been built to validate senders?
Yeah, so there are 2 major mechanisms. The first one is SPF. It's the older one. And SPF is another type of a DNS record that specifies the allowed senders for your domain. So, for example, you can state that only your MTA can send mail, or some specific IP can send mail for your domain, or, those are the 2 options, really. That way, when the recipient receives an email, they can check the origin, and if it doesn't match the SPF record, then they know that it's not from you. The problem with that is that relies on, setups fluctuate, so SPF records often become invalid. So rejecting a mail just on the basis of SPF would result in many false positives. And that's why it's not a hard rule to accept or reject email. And the other mechanism is DKIM, which is essentially a signature for the mail. And the way it works is, again, with the DNS record. So you publish the public key for the signature in your DNS record, and then you use the private key to sign the mail. And then the recipient, again, can verify that the signature matches the public key in the domain record. And the way this is problematic is also because setups fluctuate, and that's one problem. And the other problem is signing messages is not very simple. So it's simple if you're running an MTA, but it's not simple if you're just sending mail from like your own machine, which is a thing you can do. So requiring such a mechanism to be present always would cut off many people from the mail ecosystem. And for a practical example of where you send mail without any big MTA is if you're just running a script on your server and you want to get the results and you don't want to complicate the setup, you can just use SendMail, which is a Unix utility present on most machines, and you just use it to connect directly to the recipient MTA and deliver your mail. And this mostly works.
The SPF and DKIM records, are those a type of DNS record?
Yes, those are DNS records.
You would host them with your DNS provider.
Exactly. And the owner of the domain sets them up. So that's the trust part there. So you have to own the domain and have access to the DNS setup to modify them.
So what you described is if you were to strictly use those frameworks, you might end up rejecting too many emails. Given that, how widely used are those two practices?
They are used by any sender that wants to appear trusted. So I would say they are used in all of the mail going on, unless it's a hobby server, for example. There is little reason not to use them. And that also poses a problem.
If I'm a large retailer, I have 2 million customers, people sign up for email because they want to know what are the deals this week. So we're talking about a totally legitimate type of email, which people have opted in. And I want to be sure that this email doesn't run into any problems at all with any kind of filtering that might take place or spam detection. Then I would set up an SPF and DKIM, because if I am legitimate, why not? Is that more or less correct?
Yes, that's one case where you definitely want an SPF and DKIM. But the problem is that the spammers will also set up SPF and DKIM, and that's another reason why the mechanisms are not very robust. So if I set up a domain that looks like your domain with a slight difference, I can completely correctly set up SPF and DKIM for that domain and send mail that appears, it is sent from that domain and it is validly sent and it's a completely legitimately signed email, but it's still coming from a domain that is designed to mislead the user into thinking that it's, for example, their bank, which is called spoofing.
What you're talking about is the spammer can prove that the email did originate from the domain that it said. It's simply not a good domain, which is a different problem.
Exactly. And domains are also widely accessible. So there's no mechanism stopping spammers from registering more and more domains.
Let's drill down a little bit into SMTP. So you have the two sides of the protocol. What are the messages that are exchanged in an SMTP session?
A mail message looks very similar to an HTTP response. It uses the same header and body structure. So if you've seen an HTTP request, it's just the same. There are several required headers like from or to, and many optional headers, of which there's the DKIM signature header and some headers that serve other communicative purposes, or they're used for tracking mailing lists. And then there's a body, which is either in HTML or text document, or an attachment, which is base64 encoded. So it's all in all the same format as HTTP requests, just with different flavors.
The whole process from beginning to end, I would imagine a large number of things could go wrong, and we don't have time to talk about all of them, but what are some of the major things that can fail and cause an email not to get through?
All right. So first of all, I'd like to mention that SMTP is an asynchronous protocol, so it's designed to operate when your recipient is not home, and that's why it was created, because if you want to send a message, you want someone to receive it while the person may be not at their computer and will receive. So that's why you have mail servers. And first of all, you have to have a mail server running on the recipient end, and on the sender end to get the message through. But that is an obvious one. You have to have the domain records, the MX domain record set up correctly so that your MTA can find where to deliver the mail. You have to then be able to connect to their domain, and then you have to provide a valid mailbox name on that domain. And then there are internal rules such as mailbox size, because of which the receiving MTA might reject your message. So if the mailbox is full, it will reject the message. If there's no mailbox, it will reject the message. And if your email does not pass reputation checks, it will also reject the message. And all of those are called bounces in mail lingo. So a bounce is where you connect to the server, the recipient server, and it does not accept your message.
We have at this point a pretty good broad overview of email. And now I want to move into a particular more modern application, which is called transactional email. And that's something you have expertise in. I want to start out defining it. The term transaction, it's heavily overloaded in computing. What does it mean in the context of email?
Yes. In email, transactions are not the same that a programmer would be used to, because email uses the term in more of a business context. And transaction just means something happening that leads to an email being sent. So it's like an event in programmer terms, but I also don't want to attach too much meaning to the event word. So transactional mail simply means mail directed to a specific recipient for a specific individual reason. And that is in contrast to bulk mail, where you have a message that you want to send to many people. Sometimes it's millions of people, and some very different mechanisms apply when you need to send just one message versus a million.
It's not going to be helpful if I think database transaction. This is more like I bought something, and the transaction is more of a transaction in the business sense. Is that correct?
Yes.
Well, what are some examples of transactional emails, some use cases?
Well, the most transactional emails are those that have to occur at the instance that they were requested. For example, if you're receiving login credentials or if you reset a password, and then in the order of decreasing priority. So maybe you want an order update, and that could also happen instantly. So sending mail instantly is harder than sending it on a schedule or with a delay. And for example, a password you want to receive instantly, and we really are irritated when it doesn't arrive fast. And for an order update, it doesn't happen because of your actions. So while it is still directed to you personally, it's not a problem if it's delayed a bit. So maybe you want to bulk send order updates to collect them like in some buffer. And then there are some quasi-marketing emails like the welcome, the onboarding message. It might be a transactional message or usually a bulk message. And then you go into complete the marketing territory where you just send messages on a schedule.
If everything goes as expected, what is a pretty good time frame between sending and receiving an email?
Sending itself is very fast. So it would take within a second if everything goes well. And the time over that delivery time is queuing in case the MTA, your MTA is over capacity, or you might also see slower delivery because of intermittent bounces.
What are the main difficulties in implementing transactional email?
So transactional mail is usually sent by some application, right? So someone runs a web application, and the first idea you might have is that, as I said, you can just send the mail from the server you're running the application on, and the tricky part is that that's completely valid and possible. And if you're just running Linux, you have send mail, you can just send the mail to the recipient. And then you start running into problems. The biggest problem of all, I would say, is that unless you process the bounces and the spam reports that occur, so if you're not being a good mail citizen and you're just sending mail with no understanding where it ends up, you quickly get blacklisted. So a part of your reputation is how many bounce messages, how many messages that qualify as spam you send. And that doesn't matter that they are spam messages, because mechanisms are not perfect. The spam algorithms are not perfect. So anyone can send a message that looks like spam. And the proper thing to do in this case is to detect that and adjust your message, or do not send it if the recipient rejects it. And that is hard to do when you are running and delivering mail from your own server on your own efforts. So that's the big challenge. There's also the one that you have to set up all the SPF and DKIM and run signatures, so that kind of thing. But that is a one-off problem, and processing rejects is an ongoing problem that you have to do constantly.
Let's drill down into the bounce. You said bounce is a general term for many different kinds of failures. Does the point in the system where the bounce occurs generate a return message back to the sender?
So a bounce is specifically a failure that happens at the moment of delivery. So you always get a message back at that instance, and it usually describes what's going on. And by that message, you classify bounces as soft bounces and hard bounces. And this is not a well-defined distinction. It's just that soft bounces are something that might resolve in some time. For example, if the mail server is over capacity, or if the mailbox is full, that might get resolved. And if there's no such recipient, then there's no chance you're gonna deliver the mail later. So the proper way to do in such case is not send the mail again, and that's called the hard bounce.
SE Radio listeners, we want to hear from you. Please visit se-radio.net/survey to share a little information about your professional interests and listening habits. It takes less than 2 minutes to help us continue to make SE Radio even better. Your responses to the survey are completely confidential. That's se-radio.net/survey. Thanks for your support of the show. We look forward to hearing from you soon.
You mentioned that if I write a script on a server, it can correctly execute the protocols, but it doesn't have the ability to handle some of these error cases. So does that suggest an architecture where the application would submit email requests to a subsystem that's better able to deal with the failure modes?
Yes, that's the reason mail transfer agents as a service exist, is because you want some third party handling errors for you. You want them to do monitoring, and you want to know that the errors don't end up in the void. So what I didn't mention is that besides bounces, there's also a case where someone marks the message as spam, which is a different kind of error, and that does generate a separate message to your mail server, which is like another SMTP message. And you have to parse and process that, and also probably record the recipient as a non-deliverable. And processing mail messages is not an easy task to do. I've tried it in the past. I've tried to send mail from my server and process bounces and process return messages. And it's not something that can be done reasonably if it's not your main focus.
What are the difficulties in getting it right?
Well, there's just that it's a separate service to run. And then the format of messages is variable based on the recipient MTA. There's no hard standard for these messages. They're all, as I mentioned, text-based, and there are error codes, but they also vary. And the error codes have deep nesting, so you might parse a generic error code like mailbox full, but not parse the specifics. And you can't just pull up a protocol spec and implement it. That's not possible in this case. You have to, over time, collect more message formats and build your sort of database algorithm of handling the messages. And that's what MTAs do.
If a mailbox is full, I would expect to get a bounce pretty quickly, but something might sit in somebody's inbox for a few days and they mark it as spam. The indication that email was considered spam could come back much later. Is that correct?
Yes, it can come at any time.
You're sending emails and then immediately or much later you get different kinds of error codes coming back. How do you associate the error messages coming back with the messages that went out?
There's a standard for that, at least. When you send a mail, you specify something called a variable envelope return path, which is a complicated way of saying the address that you want the non-delivery report to be delivered to, and that address is an example of an address that does not correspond to a mailbox on the server, because the username, the local name in that address is an encoded string that contains usually either the message ID or the recipient address or some other, whatever your MTA needs to identify the message that failed.
Are bounces sent back by SMTP?
Well, no, bounces are just in protocol. It's like an HTTP response code. So you send a mail and you get back a status code and some text back.
Even if the bounce comes back a day later?
No. The bounces always come at the moment of delivery.
Okay.
So that's...
Right. Yeah. Okay. Something marked as spam. Is that an SMTP message to?
So to collect those, you have to not only have to send mail, but you also need to have a receiving MTA, because that's a message that's going to be sent to you. And then you have to receive the message, and then you have to parse it, find the recipient mail, find the reason for the report, and record it in some database, which you will check against when sending future mail.
What does that look like? You have a database, you've collected bounces, some of which might clear in a short time, some which are considered permanent failures. And you have these async delayed spam reports. What do you do with that information?
Well, it's not anything complicated, really. Soft bounces usually go to the same queue without a permanent record anywhere. So you just retry the message in a couple of minutes, then in an hour, then maybe in a day. And then within 2 days of the initial delivery, you just fail. Or if you just get a hard bounce, or if you get a spam report, then those records go into a table which lists the recipient's mail addresses and a status code that says, why would you not send mail to them? And some of these expire over time, like mailbox full could be expired in a week, or otherwise you just don't. When you send new mail, the recipient address is checked against the table and the mail is rejected before sending. And that is also how unsubscribes work. So you also, by the way, have to have a mechanism for unsubscribes. That is a crucial part of delivering mail in our times, because it is used by recipient MTAs to mark your messages not spam. So if you don't have an unsubscribe link, that is one of the factors that mark your message as spam.
What happens when someone unsubscribes?
They get added to the table of unsubscribes. It's, again, that part at least is very simple. So you click unsubscribe, you usually see some long encoded key in the URL. That key contains encoded information about, who you are, and it puts the information into the unsubscribe table. And a good unsubscribe mechanism doesn't require you to log in anywhere. It just works on the mail delivery layer, and it doesn't need any more information that is contained with the unsubscribe link.
We're talking about a range of different components of infrastructure, mail transfer agents, processing of unsubscribe, processing of things marked as spam. How much of this does there exist open source, and how much of it is commercial?
So while there are many open source MTAs, to name some well-known ones, so Postfix is the one that probably most people are familiar with, and it's shipped with Linux. There's also EXIM. If you want something fresh and interesting to play with, there's Haraka and Zone MTA. Those are two ones that I experimented with. But unfortunately, when it comes to actually processing the error messages and doing delivery at scale, there's no open source solutions for that, because building the knowledge base required is it requires a lot of human resource, and that's how I understand it. So first of all, people usually want to get paid for that. And second of all, it's too much of a niche product to attract many volunteers. So you don't see good open source products in that category.
What does the vendor space look like? How many vendors are there? And is it typically segmented by country or language, or are there major worldwide players in that space?
So if we're talking about proprietary MTAs as software, there are several of them, and some are, I've seen US-oriented MTAs and European-oriented MTAs, and I'm not sure if that's a big distinction in terms of what they can process, because everybody sends mail worldwide these days, or rather just the regional flavor, I guess. But what I can say is that that software is usually employed by companies like hosting providers or big enterprises that need to send mail for their clients. Or if you're building your own MTA, so you might use one of the solutions and then build your business logic on top of that. If you want to send mail for your application, you usually want some software as a service. And that is because the licensing costs of proprietary MTAs do not suit individual senders. And on top of that, you also have to run your own infrastructure, which might get complicated and expensive if you're sending at scale.
Next thing I want to talk about is testing. How do you go about testing transactional emails with so many pieces and it's so highly distributed?
To test mail, you usually deliver it to someone. So you want to exercise the protocol. Otherwise, you just stop the delivery. So historically, what people have done is just send mail to their own account, their own mailbox, and see what comes up. And incidentally, working at Mailtrap, so we built the service to serve as the submission MTA that will collect your mail and then collected into a mailbox so you can see what your application is sending instead of using your own mailbox for that, because there are many issues with sending mail out into the world, even if it's into your own mailbox. The first of all being that you might send to the wrong mailbox, to the wrong people. So if you have some staging environment and you have real user emails, which happens, I've seen that happen, and you send mail, like you're testing a mailing list, and you send mail to everybody on the server and you spam real people. And that is always a problem. Sometimes it makes the news. And to avoid that, we built Mailtrap, which is an MTA that instead of delivering mail to the recipient, collects it and displays it and gives you all sorts of analytics. So that's a kind of solution you want to have when testing that your mail would be delivered correctly. So what you want to see is if your application is composing the email correctly, if you have the right headers you want, if your message looks right, and if it doesn't qualify as spam based on the contents. So there's software called Spam Assassin that analyzes the content of the message itself, if that looks like spam. And it's one of the factors used to analyze, to sort spam messages from non-spam. So you want to see that your message scores well on Spam Assassin. You also want to see if the application you're sending from is not on a blacklisted server, if your domain is not blacklisted. So those are things that you want to know before you start sending email to real customers.
You mentioned blacklisting a couple of times, and the first time you said it, I wanted to ask you a question, and then I forgot. Describe who maintains a blacklist and how do servers either get on them or get off them?
Yeah, so there are many companies, many third-party companies that operate blacklists. And the idea of a blacklist is, well, it's a list of IPs or domain names that are not trusted, reliable email senders. And that doesn't mean they send spam necessarily. It's important to understand that, well, there is legitimate spam. There's also mail that is either unsolicited or it appears like spam. And you don't want to send those messages because you get blacklisted. So there are two parts to reputation management in mail. So there are two kinds of blacklists. One is attached to domain names, and those are the domain name that you're sending from. So, for example, if you, as I mentioned, if you're a spammer that tries to phish passwords out of users by appearing as a domain of some bank, then your phishing domain might get blacklisted because it sends spam. And the other kind of blacklists is IP blacklists, and they serve a different purpose. So spammers usually abuse machines on the internet, and that's also a huge, interesting area. So the main purpose actually to hack into servers these days is to send mail from them. You want some fresh IPs. That's what hackers are against. They usually don't want to steal passwords unless you're someone big, but they do want to get your IP because every fresh IP is an opportunity to send some mails before getting blacklisted. Once mail recipients see a large volume of spam coming from some IP, so they cooperate with these blacklist companies and they collect the information about which IPs are sending unsolicited mail. And sometimes the blacklists operate in a matter of minutes or hours. So they're very highly dynamic, because if someone hacks a machine, they just start abusing it right away. And it's important to stop the activity as soon as it happens. And to get off such a blacklist, so there's, again, I think there's maybe 20 or 30 companies that run blacklists. And you usually use a tool to see if your domain or IP is listed. And then you can appeal to the individual company and ask to be removed from the blacklist. And the way you actually get on the blacklist as a legitimate sender is either you inherit an IP that has a bad reputation. So that happens with cloud providers. Although recently, I think like Amazon cracked down on spam sending. So you can't send mail from Amazon machines before they approve you. So that helps a bit. So the IPs are more clean. But in the past decade, it has been big problem that if we were with a cloud provider, you get an IP and it's already blacklisted. Or another case is if you run mail and, as I mentioned, you don't check if it's qualified as spam, and you eventually get blacklisted unknowingly. And then hopefully you start investigating the issue, you see you're blacklisted, and you learn from the mistakes.
We have, in the last few minutes, I wanted to talk a bit more about bulk email. You've mentioned scale a couple of times in the context of you could have a very large number of transactional emails, like a very large number of order updates, or businesses so large that you're doing a large volume of password resets. What are particular challenges if I have a mailing list with 2 million people and I want to get out 2 million emails in a reasonably short span of time, like maybe overnight, to let everybody know what are all the sales or specials going on in my business the next day?
That's an important target to meet. So many emails are time sensitive. Order updates are maybe not the most time sensitive, because imagine you have to send calendar event updates or like flight cancellation updates, and you really want people to receive them right on time. Order updates, of course. And when you need to send many messages at once, you usually use an MTA that's tuned for not transactional mail, but bulk email. And they have a bigger array of machines to send from, but also they can. So a lot of time that it takes to send the mail is preparing the mail to be sent. So templating, for example, is an obvious one. So you have to you have to render the mail, and a bulk message system would render many mails more efficiently than one by one. So that's when you go to a bulk sender. But I have to state that the bulk sending and transactional sending are two categories that, while they intersect, you usually know if you want one or the other. And I would suggest people to start with transactional senders while they're small, because they are more controllable. They're event driven. You can send just one mail, and with a bulk sender, you usually have to submit like a mailing list. So start with a transactional sender. And when you get to that million of customers, you might transition to a bulk sender.
We've reached the end of our time. Is there anything else you wanted to cover that we haven't talked about before we wrap up?
Not really. Again, to repeat my suggestions to people who start out sending mail, I suggest use email as a service, MTAs as a service, because you avoid many rookie problems. Test your mail before sending, and don't send spam.
Where can listeners find you on the internet?
They can find me personally at l-s.me. I have a blog on technology. They can find many interesting things on mail on the Mailtrap blog at mailtrap.io/blog. that's it.
Leonid, thank you so much for speaking to Software Engineering Radio.
Thank you.
This has been Robert Blumen. Thank you for listening.
SE Radio listeners, we want to hear from you. Please visit se-radio.net/survey to share a little information about your professional interests and listening habits. It takes less than 2 minutes to help us continue to make SE Radio even better. Your responses to the survey are completely confidential. That's se-radio.net/survey. Thanks for your support of the show. We look forward to hearing from you soon. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.